Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to use the combined gas law equation to solve gas problems. So the first thing you want to ask yourself when you're looking at a gas law problem or a problem involving gases what is there a change going on in the problem, right? So you're either going to use the gas law combined gas law problem, or you're going to use the ideal gas law equation. So either the combined gas law equation or the ideal gas law equation to start with. So to determine whether you're going to use one or the other, you have to look at the problem and say, is there a change? Is there a change in any of the conditions of the gas? So is temperature changing? Is volume changing? Is the amount of gas changing? Or is it, two of those, more than one changing at the same time, right? So anytime that there's a change, you're going to use the combined gas law equation. If there's no change going on and they're just giving you a set of conditions and saying, hey, here are the set of conditions, what's this condition here, right? So if they give you the volume, the temperature, and the amount of the gas, then they might ask you for the pressure. In that case, you're going to use the ideal gas law problem, or ideal gas law equation. So let's look at this problem. So it says we have a helium weather balloon that has a pressure of 102 kilopascals, a temperature of 18 degrees Celsius, and a volume of 1.6 times 10 to the 4 liters. And then what is the pressure, they're asking us? Oops, I misspelled pressure. Okay, misspelled pressure. Okay, hopefully those grammar people out there don't have a conniption. So, what is the pressure when the temperature is negative 8.6 degrees Celsius and the volume increases to 4.7 times 10 to the 4 liters? Okay, so first thing you want to do is write out the things that they're giving you, right? Label the things or the data that they're giving you. So to begin with, we're told we have 102 kilopascals. So the gas in the helium balloon, the weather balloon, it has 102 kilopascals. So that's what we're starting with. So the P1 is equal to the 102, kilopascals. 102 kilopascals. And we're told there's a temperature of 18 degrees, so that's what we're starting with. So that's a initial temperature. Temperature 1, not I, temperature 1 is equal to 18 degrees Celsius, but we got to convert that to Kelvin, so we'll just do that right away. So we'll add 273.15. Okay, so when we add that, we get 290, or let's see, 291.15. So 291.15 Kelvin. And we're given a volume of 1.6 times 10 to the 4. So that's our V1. So that's 1.6 times 10 to the 4th power liters. Okay, now what happens after? So presumably we're letting the balloon go. It goes up into the air. It gets colder as you go up into the atmosphere, so the temperature is going to decrease. And so less pressure, less air pressure is out there. The atmospheric pressure decreases. So that's going to allow the balloon to expand. And so that what we see an expansion here. And we want to know what is the pressure. So we have our new temperature. So that's going to be our T2. And that's going to be negative 8.6 degrees Celsius. We're going to add 273.15 to that. And so what do we get? So we're going to subtract this from this, and we get, let's see, 270, 264 point something. Let me calculate that really quick. And that's 264.55. So that's going to be equal to 264.55. Okay. And that's going to be Kelvin. And then we're given the new volume. That's going to be our V2. V2 is equal to 4.7 times 10 to the 4 liters. And we're trying to find the new pressure, P2. And that's equal to question mark. We don't know. That's what we got to find. Okay, so now I have everything labeled. Now we're going to go to our the combined gas law equation, which is going to be P1 V1 over T1 N1 is equal to P2 V2 over T2 N2. Okay, so this is really, when it comes to the gas laws, this is really the only one we need to know besides the ideal gas law. But even then, the ideal gas law gives us this anyway, but that's for another video. I have another video where I show the derivation of that. So this one is the one to remember, because you can get all of the other equations, the Boyle's law equation, the Charles law equation, the Gay-Lussac law equation, the Dalton's law equation or whatever, by paying attention to what is constant, right? Because whatever's constant or not even mentioned in the problem, you can eliminate from your equation, right? So if it's constant, it's not going to be a factor. So what is missing in this problem? What do they not talk about? And if you say the amount of the gas in the balloon, you would be right. We can assume that that's held constant. So that is our N1 and N2. So those can be eliminated. So we can just erase that from our equation. And what you're left with is this equation here. So then that's the equation we're going to use to solve the problem. So now all we need to do is plug in our values, solve for the missing part, P2. So let's go ahead and do that. We have P1, 102 kilopascals. So we got 102 kilopascals multiplied by V1. Where's our V1 right here? 1.6 times 10 to the 4. 1.6 times 10 to the 4 liters. That's going to be over T1. Our T1, where's our T1? Right here. So that's going to be 291.15. 291.15 Kelvin. That's going to be equal to P2 times V2. So P2 we don't know. We'll just put that in there. So P2 is what we're looking for, multiplied by our V2. What's V2? V2 is 4.7 times 10 to the 4. So 4.7 times 10 to the 4 liters. Okay, so now we have our T2. Our T2 is 264.55. So 264.55 Kelvin. And now we just solve our equation for P2. So we're going to multiply by this on both sides. We're going to divide by the volume on both sides. And then we get what? We get 102 kilopascals multiplied again by 1.6 times 10 to the 4 liters. And then that's going to be multiplied by 264.55 Kelvin all over. That's going to be 291.15 Kelvin multiplied by the 4.7 times 10 to the 4 liters. And this is equal to P2. All right, so now all we need to do is multiply and divide, but let's look at our units. Our units should cancel out except for a pressure unit. So here we have our Kelvin and our Kelvin. I almost said potassium. So Kelvin cancels out liters here, cancel out liters there. So everything cancels out except for kilopascal, which is a pressure unit. So we are good to go. So now all we need to do is calculate the answer. And when we do that, we get 31.551. So that means that P2, the new pressure is, oops, hold on a second. Sorry about that. So we're going to get, what did I say the answer was? 31.551. So 31.551. And that's going to be kilopascals. And so let's talk about sig figs now. So for those of you interested in sig figs, the rule for sig figs when you're multiplying and dividing is that your answer should have the same number of sig figs as the measurement with the least number of sig figs. So let's look at our measures. We have 3 sig figs here. We have 2 sig figs there. We have 5 here. We have 5 there, and we have 2 there. 2 being the least number. So we're going to have to cut it off at 1 and 2. So after here, so that means that we're going to have to round this to 32. So the pressure, the final pressure is 32 kilopascals. So that, ladies and gentlemen, is the final answer. So this is how you use the combined gas law equation to solve this problem. If you enjoyed this video, if this helped you in any way, then please like the video, hit that like button, share the video with your friends. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you would like me to solve or help you through, I would love to do that for you, as well as any topics you want me to cover. Thanks for joining me, and have a great day.